Okay, here's number 9. I'm sorry I had to do this one on graph paper because I accidentally deleted the video after I wrote it on paper, so I only had one blank copy. So we've got y equals 3 times x minus 1 squared minus 1. So once again, I'm going to write my general form down. We see it's y equals a times x minus h squared plus k. I want to identify the a, the h, and the k. The a is the number up front. That's 3. Because it's positive, we know that this graph's going to open up. Remember the trick with the h and k. Switch the h, keep the k. Because the word switch has an h, the word keep has a k. So I see negative 1 in the parentheses, so I'm going to switch that sign and make h positive 1. Keep the sign of the k, I see negative 1. HK is our vertex, 1, negative 1. So 1, negative 1. I'll draw that axis symmetry. So like those of you who have to draw your own graphs, I know I'm fortunate to have some graph paper, but I know this is a large graph. But we need to practice doing some graphs where those a values are greater than 1, so we have practice stretching out the graph. Okay, our a value, we just said, was 3. Now remember, we multiply across these columns. 1 times 3 is 3. 3 times 3 is 9. Those are positive numbers, so the vertical change is going up. As I stated before, because the a value is positive, just like when we did standard form graphs the last week or so, if a is positive, it opens up. Horizontal change has nothing to do with this table. It's always 1 to the right. So the first move is up 3, so I count up 3 units, over to the right 1. And from the second point, I need to go up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, over 1. Using the idea of symmetry, I'm going to reflect those points over. And I'm going to try my best to draw a smooth curve through these points. I know when the points are farther apart, it becomes a little difficult to do that. But also make sure that all graphs have all 5 points, and none of these 5 points are on the same vertical line. Okay. The domain, all real numbers. The range, as we said, always deals with that k value, the y coordinate of the vertex. This one opens up, so it's greater than or equal to negative 1. Every y coordinate, everywhere on this curve, every point on that curve has a y coordinate greater than or equal to negative 1. There's never going to be any points down here.